Video number 198, function operations and function compositions. Let f of x equal 3x squared minus 10x and g of x equal 9 minus 7x. The first what we're going to do here on this page, we're going to take a look at f g of x, which basically means the function f times the function g. Okay, so what we could do is here, now I didn't type this in here, but let's just go ahead and write it down so we got it, is that we could say that f g of x equals f of x times g of x. It means times, not composition. That's something different. That's what we're going to be doing here later on in the show here. This is the definition of composition. This is f composed g of x, which would mean f of g of x. Okay, we'll get to that later. Now, very simply, we're going to multiply f times g, and we're going to do the FOIL process, or however you want to do it, distributive property, distribute to 10 twice, distribute to 3, you're all set. So bam, there's your like terms after you do first, outside, inside, and last. There's your common like terms right there for the 97x squared. And we just list everything in descending order. Okay? Then subtraction. So you got f minus g of x, basically means the same thing, except instead of having a multiplication symbol in the middle, obviously we're looking at f of x minus g of x, and we're in good shape. Okay, so we would go ahead and subtract, and that's going to allow us to change the minus sign in between, in the middle is binomial, to a plus. You just add the like terms. That's a negative 3. Bring the 9 down. There's a 3x squared. You're all set. Next one, f plus g of negative 2, or f plus g at negative 2. Well, there's two ways to do this. Here's one way to do it. This is key right here. F plus g at negative 2 is the same as f at negative 2 plus g at negative 2. So either way, we're actually going to calculate both to prove this. Here's the one here where we're going to actually plug in negative 2 after we add the f and g together. Okay? So f plus g ends up being 3x squared minus 17x plus 9. If you go back and add those together, that's what you get. Okay, if you were to add these up. Alright. Then, okay, we go ahead and, calculate negative 2 squared times the 3. We just do all that stuff, and we get 55. Now, the other way to do this would be to use the negative 2 into each function. So f of negative 2 plus g of negative 2. And then there's your f of negative 2, which is whatever that is. This is g of negative 2, which is whatever that is. You add it up, you get 55 either way. So I just wanted to go through and show that it doesn't matter what order you do it in. Next one, function compositions. This is pronounced f composed g of x, or f composed g at x. That would be the same thing as f of g of x. So that's this symbol here, the clear circle, not like this. This meant times, f times g, okay? So when the two functions are right next to each other, that's multiplication. This is f composed g, which basically means take g of x, you basically work backwards, take g of x and plug it into f. That's how it all works. So, to find f composed g at 2, we would take g of 2 and plug it into f. Well, g of 2 is 9 minus 14, which is negative 5. Then we would take we would then try to find f of negative 5. Okay? So you got g of 2, which is negative 5. Now you find f of negative 5, and bam, you get 25. Because you just get 3 times the 25, that's 75 minus the 50, so you're all set. All right, so that would be function operations, and we did one composition. I'm going to have another video on function compositions with domains. So good times, and we will talk to you later.